Okay, hi guys. So in this lecture, we'll be seeing a new concept which is known as Osazone Formation. Okay, so which is basically used for the determination of C2 epimodes. Okay, so let's get started. So let me first write down the heading. So we'll be first discussing Osazone Formation, which is basically used for determination of C2 epimers. Okay, so let's say we have D-glucose. So D-glucose will be something like okay. So now when we actually pass it, this is D-glucose. When we actually pass it in basic medium and in presence of 3 moles of NH2 in basic medium, what will happen is we will get something like this. pH, and then the rest of the structure remains same. Okay, so let's discuss the mechanism for the same. So mechanism is nothing but first our aldehyde group, or better let me write down CH double bond O and OH here, and rest of the chain I'm just drawing it, I'm just symbolizing it. Okay, so NH2 NHPH, obviously dehydration will take place with this water molecule being removed from the two compounds, and as a result we'll be getting something like this. This is carbon atom, and pH here, and similarly we will get OH, H, and rest of the chain here. Okay, so next what will happen is it will undergo tautomerism. Okay, and as a result we'll be getting something like C here, NHPH here, okay, and C OH here. Okay, and rest of the chain still remaining the same. Next, when it undergoes what actually happens in basic medium is I'm just trying here. What happens in basic medium is we'll be getting something like this O minus would be attacking on this H plus. As a result, it will be forming double bond here, and this bond will come to here, and this will be removed as a N minus. So we'll be getting something like C double bond N, CH double bond NH rather, and C double bond O here, and rest of the chain here. Now what will happen is it will again react with 2 moles of pH NH NH2. So as a result we'll be getting pH NH NH2 here. Okay, and NHPH here, and similarly we'll be getting the same compound here. So we'll be getting something like, so NH3 from here would be removed. Okay, and obviously water molecule from here would be removed, and as a result we'll be getting something like this N comes here, N and NHPH, and similarly we'll get C double bond O and single bond NHPH, and then we'll be getting the same thing, same chain here. Okay, so total 3 moles of NH2, NH, were consumed in the reaction. Obviously, the byproducts of or the leaving products would be, one is NH3 and another is water. Okay, so this is the formation of Osazone. Okay, so the reaction is not similar as before if the pH is in the range of 4 to 7, but now we are using the pH as a pH in mild basic conditions, or mild basic pH we are using. Okay, so mild basic conditions are applied. Second point is D-glucose, D-mannose and D-fructose which will form the same Osazone. Okay, so D-glucose, D-mannose, why? Because they have same enolic form. D-fructose will form same Osazone product or same Osazone. Okay, next is let us now discuss the characteristics of this reaction. Okay, so the first characteristic is obviously 3 moles of pH NH2 will be consumed in this reaction. Okay, so let's write it down, that three moles of this reagent will be consumed. Okay, so next point is C2 carbon will lose its chirality in Osazone formation. Okay, why? Because both of the carbons get converted into aldehyde and then attachment of C double bond N bond takes place. Attachment of N towards C takes place via double bond. Okay, so C2 carbon will lose its chirality in Osazone formation. Okay, next point will be C2 epimer will form the same Osazone, as we have already discussed about mannose, fructose and glucose, that C2 epimers will form same Osazone. Okay, then we'll be discussing some more on special type of rearrangement in the next coming lectures. Okay, so I'm just not writing it, but just in a point form I'll write it, that D-glucose, D-mannose and D-fructose will form same Osazone, and this is Acostine rearrangement. Okay, so with this we come to an end of this lecture. In the next lecture we'll be seeing more examples on the same, and we'll be seeing more interesting reactions of the carbohydrates, and then we'll be seeing cyclic structure of glucose. Okay, so till then, good luck and goodbye.